So the first thing that I want to say, guys, is that on the weekend, I asked y'all to make sure that you have a notebook, right, for taking notes and some writing utensils. So today is going to be a day where I want to teach you guys some ideas. I want to teach y'all some topics in math, particularly about functions. What is a function? This is kind of like, this is the question that we're trying to answer today. What is a function? And I would really like you guys to take notes. Now, I know that taking notes is an idea that kind of is very vague in our classes a lot of times. So what I'm going to do is I'm going to try to help you guys out. I'll try to point out things that would be useful to take notes on. And however, at the end of the day, guys, taking notes is really a skill which is important for you to do for yourself, right? Taking notes is kind of like, I know that a lot of teachers will teach us kind of different styles of taking notes, right? Like Cornell notes and such. At the end of the day, the best thing that you can do is find what works for you in taking notes. For myself, I can show you guys what I do. For myself, when I take notes, I almost exclusively do everything in like bullet points. For some reason, that just is what makes sense to me. So you can see like in my notebook, and this is, I use this notebook for like taking notes on my class lessons and stuff. You can see I kind of like, everything is just like bullet points and like lists of ideas with like maybe a lot of like things that kind of go in, like build off of each other. So you can see in this one, I've got like, it just like lists upon lists of ideas and like things that build on each other. That's how I take notes. But really, you guys are welcome to take notes in whatever format works for you. Okay. I'm just going to point out some of the ideas from today's lesson that I think might be worthwhile to take notes on. Okay, so first of all, what is a function? Is this a simple question? What's going on, right? So guys, first of all, this is the definition of a function. A function, right? A function is a relationship between inputs and outputs. Now, that sounds like a simple enough sentence to define what a function is, but I think that we could break this down a little bit further because it kind of is, I think, a little bit too, there's like two new words here, inputs and outputs. What do these mean, right? If a function is a relationship between inputs and outputs, I should probably know what those are. So for example, guys, some examples of things that could be functions. So I want to kind of give us some examples of things to have in mind for kind of real world context. So an example of function could be like the relationship between the amount of pizza I buy over at Arizmendi and how much that pizza ends up costing, right? There is a relationship there, guys. The more pizza I buy, the more I have to pay, right? That's a relationship. That's a direct relationship, linear. Another possible one, if I plant some seeds and I have a plant growing, as time goes on, the plant will grow bigger, right? That's a relationship between time and the height of the plant. Do you guys get what I'm saying? Another possible relationship in a tournament, right? Are you guys familiar with this structure for like a tournament here? Brackets, tournament bracket. In a tournament, as we go down the rounds, right? As more rounds pass, less and less teams will exist because with each passing round, you notice two teams play each other, one team moves on. Two teams play each other, one team moves on. So every time we pass a round, we have the number of teams. That's a relationship between the whether I'm in round 1, round 2, or round 3, and how many teams exist still in the tournament. Yeah. So let's break down what are inputs and outputs. So an input, so some examples of inputs are variable pieces of information. Okay, guys. The inputs are basically, it's like information that I could be given or that I could know. So for example, in my pizza scenario, an input would be something like how many pieces of pizza am I buying, right? That's the input. It's variable, isn't it? I could buy one piece of pizza one day. I could buy two pieces of pizza the next day. I could buy three. I could buy 4, 5, 6, 7, 8, right? You could keep going. I could buy as many pieces of pizza as I can afford / want. Other examples of inputs. How long has the cilantro been growing, right? So here I planted some cilantro. The input would be something like, how long has it been growing, right? That's the information that's important, right? It's the information that I'm observing. Or for example, how many rounds have passed in the tournament in my tournament bracket, right? Okay, so those are inputs. Inputs are basically just variable bits of information that we can observe, right? What are outputs? Outputs are the outcomes resulting from the input, right? It's like what happens because of the input. So for example, in my pizza scenario, if I know how many pieces of pizza I'm buying, right? The output would be, well, then how much does that pizza cost, right? It's like the conclusion I can make based upon my input. Does that make sense, guys? Another example of an output could be, how tall has the cilantro grown? If I know how long it's been growing, then I could also know how tall it is. Or I could observe if I know the relationship between that. Like if I know that my cilantro plant is growing by 1 centimeter per day, then after 5 days, it would be 5 centimeters tall, right? 5 days being the input, 5 centimeters being the output. Or for example, the output could be how many teams remain in the tournament, right? If I'm on the second round, there are 1, 2, 3, 4 teams left in this tournament here, right? If I'm in the third round, there's 2 teams left, right? So at this point in time, guys, I want to give people a chance to catch up on taking any notes if they need to. So I would suggest y'all please have this information, right? This definition of a function, right? And then we're defining inputs and outputs in these boxes. Along with examples, I always think, guys, it's important to have examples when you're defining things because it helps us kind of understand it in a context. If anyone has questions about any of these terms, right? If you want to ask me about the inputs, ask about the outputs, ask about anything, please feel free to post in the chat and we'll discuss. Alrighty. So guys, so that's what a function is, right? Functions are relationships and they connect information basically. So something that is like, for example, y'all ever seen the Avengers Endgame? So like in Avengers Endgame, in Avengers Endgame, or no, this is I think from Infinity War, not Endgame. I think this scene is from Infinity War, but whatever, same thing, right? In the Avengers movie, Doctor Strange does this weird thing where he's like analyzing all of the possible futures, right, in their battle based on all of the different like strategies they could take. Do you guys, if you've seen the movie, do you guys remember this? And so then what happens is that they say, yeah. So what happens is then Iron Man's like, okay, well, how many futures did you see? Right. And he's like, I saw 14 million futures. And he's like, how many did we win? 1. Right. What's happening here, guys, is that Doctor Strange is looking at the set, right? The set of all possible options, right? How could they attack Thanos, right? How could they fight Thanos? What can they do? He's essentially doing his superpower to like analyze all of these possible options. And those are the inputs, right? The strategies are like the inputs that he's like looking at. And then he follows the relationship between each strategy to predict the future outcome, which would be the outputs. So he's like, oh, well, if we have Thor attack him in this way, then the outcome is we die, right? And he's like, if we have Iron Man attack him this way, the outcome is we die, right? So he's essentially relating all these strategies with like the possible future outcomes. This is my analogy for what a function is. So if you become a math wizard like Doctor Strange, then you too can predict the future. Maybe not as epically as him though. You won't like float and have your face look in all different directions. All right. So guys, that's like what functions are, right? But it helps for us to kind of wrap this into the math a little bit and see how this works. So essentially, guys, commonly in math, we use variables. Y'all should be familiar with the idea of variables. They're things like X and Y. They're all those letters. And the idea of variables, guys, I want y'all to think about this, right? Variables are simply representations or placeholders, right? Sounds good. Let's see. So essentially, guys, in my equations, right? In my equations in math, I have these sort of like sentences, right? So an equation is kind of like a mathematical sentence, and we use equations to describe relationships such as functions. So for example, guys, if a person wears 3-inch platform shoes, what happens to their height? What do you guys think happens to someone's height if they wear some platform shoes? What happens to someone's height when they wear platform shoes? Here's, let's have Alberto. We got Alberto here. He's smiling. We'll give him a little baseball cap. And he puts on some shoes that are really tall. What has happened to Alberto's height? What do you guys think? When Alberto puts on the 3-inch shoes, his height expands, says Alan. Yeah, how much more does his height grow? How much bigger does his height get?
I meant to say that it increases, but 3 inches.
Yeah, exactly. Thank you, Alan. So what, Alberto, do you mind sharing with us, how tall are you? Dang. All right. Let's say that Alberto is 5'4". All right. Now, it'd be weird if we wrote this in feet and inches, but then have this guy in only inches, right? So I'm gonna convert this. 5 feet is 60 inches. So let's say that Alberto is 64 inches tall, right, guys? Then his new height with the shoes on is 64 plus 3, 67 inches. You guys see that? So basically, all we're doing is that we're taking their height and we're adding 3 to it, right? That's what this function of wearing platform shoes does. It takes your height and it adds 3 inches, right? So it can be modeled by a function, which is y equals x plus 3, where y is the person's height with the shoes, and x is the person's height without the shoes. So check it out, guys. Essentially, our input here in this equation, our input is that x value. And what we're doing is we say, okay, notice, guys, x is not a real number, right? It's just a variable. It's a placeholder. It exists to literally show us, okay, well, if I don't know the person's height, what's happening to their height? And then as soon as I know their height, I replace x with it. Let's say Brian is he's 6 feet tall. Yeah, we're gonna make Brian 6 feet tall. If Brian is 6 feet tall, that is 72 inches, right? Oh, wait, where's my annotation? If Brian is equal to 72 inches, then what I do is I take this 72 inches and I make it my input, right, guys? And I plug it in for X. If Brian's height is 72 inches, what would be his height with the shoes, the output? What would be his height with the shoes, the output, guys? So see how I've replaced the X with his 72 inches? So we get that Brian's height with the shoes is 72 inches plus 3, 75 inches. Ooh, by the way, guys, when we're working with units, I should listen to myself. We include the units. So see, I wrote 75 in for inches. Right, guys? So this is kind of like me showing y'all a little bit about how does functions work? How do functions model things? How do equations model functions? So check it out, guys. Here's a table, right? So oftentimes what we'll do in math, when we have an equation for a function like this, we'll create a table. We call it an XY table. You may have seen these before. And what we do is in this table, we just collect data about this function. So if we said before that Alberto was 74 inches, and then when he wears the shoes, he's 64 inches. And when he wears the shoes, he's 67 inches tall, right? If someone was 62 inches tall and they wore the 3-inch platform shoes, they'd be 65 inches tall, right? And so on. So what this does, guys, is that this table of values gives us those x, y coordinates, right? See how it's x and y? So together, I have an x, y coordinate pair. This is just like those graphs we were looking at before. Remember that, guys? We've been looking recently at all this stuff with graphs and plotting coordinates and such. And so check this out. If I were to create a graph using this data, it would look like this. See how I know it's kind of small, but I'll do it I'll rewrite it over with my annotation. So check it out, guys. This here on the x-axis says 61, 62, 63, 64, 65, right? And over here, this says 64, 65, 66, 67, 68. So check it out, right? When X, our input, is that the person is 62 inches tall, the output Y is that with the shoes, they're 65 inches. So look at, here's 62, comma 65 right there. This point right here is at 63, comma 66. You see that? So what we're seeing here, y'all, and what I'm trying to show you guys is that these graphs exist. Graphs exist to show us what functions look like, right? To show us the growth of functions, the modeling of them, right? And what are functions? Functions are relationships, right? They relate to different values. Oftentimes we use X and Y, but we could use different things, right? We can use all sorts of different variables to represent ideas in the world. And that's what math is all about, guys. It's about representing ideas in the world in this abstract math language, because once we're in the math language, there's so much you can do with it, right? There's so much more we can understand in the world once we're working with math. So this is a bit of kind of my spiel for you guys about how functions works, okay? Something I would like you guys to make sure that you have written in your notes, please, is, hey, wait, let me go back for us. You don't need this. You don't need my Doctor Strange analogy in your notes. This is just something that I thought was fun. So we had this guy about inputs and outputs that we talked about. And then I would suggest that people have this information here written down as well about in math, we use variables to represent the inputs and outputs. Equations are the mathematical sentences. So notice mathematical sentences. I like this term because it's like, imagine guys, you have English sentences, right? Which you're doing in Mr. Murray's class and such. But in our math class, we work with mathematical sentences, and that's what these equations are. They basically, equations exist to describe things. And then we have this example, and I actually think that this example is a good one for us to have as well. I don't really think that you guys need to plot this graph. You don't really need this in your notes. Okay. Cool. And so something I'm gonna do, guys, is I'm gonna actually share these I'm gonna share these slides with you guys. That way, if I move on and you need to see something from before, you can always open them up right there. And I'll post these slides as well on Google Classroom when I post the video. All right, y'all. I'm gonna erase this annotation. So I'd like to do, before we split today, guys, for class, before we split up class, I want to do a little bit of a practice identifying inputs and outputs, y'all. So recently, Mr. Hobaugh has been watching The Mandalorian. So let's say that Mr. Hobaugh decided he wanted to be able to stream shows like The Mandalorian on his TV, right? Don't worry, Danny, we're almost done. A subscription for Disney Plus is $7 per month, guys. So for every month that I pay for Disney Plus, I have to pay $7. And a Chromecast for me to stream the shows and movies onto my TV costs $50. So let's suppose I want to stream these shows on the TV, right? I don't want to just watch it on my phone. So I need to buy a Chromecast for $50. And for every month that I'm watching, I have to pay $7 as well, right? Now, this relationship here, guys, is actually a function. This is a function right here. I'm paying $7 per month with an upfront cost of $50. What you see here, guys, is that I can represent this relationship as y equals 7x plus 50, where x, you can see, is the number of months. X is the number of months that I've been paying for my subscription to Disney Plus, and Y is the amount of money I've spent, right? So I spend $50 right away for the Chromecast. How much have I spent in total after 1 month, guys? When X equals 1, how much have I spent in total? If I bought a Chromecast and I've paid for 1 month of Disney Plus, how much would I have spent, y'all? I'd like you guys to please post this in the chat, okay? In the chat, please tell me how much in 1 month would I have spent in this situation? All right. I think people are so focused on writing down the notes. Of course, makes sense, guys. In your notes, I would suggest that I would like you guys to please copy down this table, by the way. and have above it our scenario and our equation, please. So these three things that I've circled or that I've boxed, I would like you guys to make sure that you have in your notes, okay? And what I want us to do is I want us to be able to fill out this table. This might be saying that we need to wait until next time to go over the answers on, but I would like you guys to try it out, okay? I'll do the first one for you guys, all right? In 1 month, right? In 1 month, I'd pay $7, right? Because I pay $7 per month, plus the extra 50. So I'd pay a total of $57. Does that make sense, y'all? You can also see it by having plugged it into the equation, right? If I plug 1 into here, I have 7 times x, that's 1. So 7 times 1. So I have y equals 7 times 1 plus 50, right? 7 times 1 is 7. 7 plus 50 is 57. What if I had 2? What if I had paid for 2 months of Disney Plus? All I do is I take 2 and I plug it in for x, right, guys? So I've set y equals 7 times 2 plus 50. 7 times 2 is 14. 14 plus 50 is 64. So I'd have paid $64 in 2 months. You guys see? You could keep going with this and so on. So we'll look at this more next time, guys. But otherwise, I'm going to start wrapping up class. I'm going to stop the video recording. So if anyone is watching this on the video, bye-bye.